Algebra 2. This is Unit 13, Statistics. It's our last unit. And this is Lesson 1, Statistical Studies. So statistics is the science of collecting and analyzing numerical data. There are three types of statistical studies that you can do. Surveys, where you're going to collect data. You might have seen people like in the mall with a clipboard, and they ask you to stop and answer a survey and answer some questions. People might call your house at night to ask you to answer a survey. A second way is observational. So an observational study, you're merely just observing. All right, you're not doing anything to influence the outcome in any way. All right, you're just observing. And then the last way is an experimental study. So an experiment, think science, you're actually going to do something to influence the outcome to see, if you can affect change one way or the other. And we'll give examples of each of these down below. So the objective of an observational and a survey is to learn about the characteristics of some population, so the data should be collected in a way that would result in a representative sample. The objective of an experimental study is to answer such questions as what is the effect of treatments on a response variable. Data in an experiment needs to be collected in a way that does not favor one treatment over the other. So let's talk about an observational study, one in which the values of one or more variables are observed with no attempt to affect the outcome. So this right here is important. You're just observing. You're not trying to affect the outcome in any way. Data is simply gathered and correlations are investigated. Okay, an example of this, if you wanted to see how many people wear masks. Well, you could merely just go into a class and count. Or walk down the hallway and count, right? You're just observing. You're not doing any experiment of any kind. You're not asking people, do you want to wear a mask? Don't you want to wear a mask? You're observing who's wearing a mask and who's not wearing a mask. Okay? A survey requires asking a group of people to respond to one or more questions. A poll is an example of a survey. So you might do a survey to see which breakfast cereal people prefer. Right? You might do something like this in a supermarket or outside a supermarket. You want to make sure, though, that you have a random sample. So we're going to talk some more about this, but you need a random sample of people. All right, you wouldn't want to stand outside of a health food store because people who are shopping in a health food store are probably eat more healthier cereals, so you wouldn't get data from everybody. You always want to make sure that you're getting data from all of the population that you're trying to do the study for. An experiment randomly assigns subjects to treatments for the purpose of seeing what effect the treatment has on some response. Okay, so think cause and effect. The subjects could be people, they could be animals, or any set of items that produce variability in their responses. So say I have seeds and I want to test out to see if a fertilizer works. So I can divide them into two groups. One gets the fertilizer and one doesn't. So you're trying to see the cause and effect. So you want to know what proportion of the population likes rap music. You carefully consider three ways to conduct a study. Classify each as an observational study, a survey, or an experiment. You pick a random sample of people and ask them the question, do you like rap music? And record their answers. Well, that would be a survey. Okay, you're just doing and notice it says random. All right, but you pose them a question, they answer the question, that's a survey. Part B, you could pick a random sample of people and follow them for a period of time, noting that their music purchases in stores and online. All right, that would be a little bit time consuming, but that would be observational. Okay, not that you would actually do that. I'm just trying to show you an example of, with the same example, what could you do? So just following them around and seeing what kind of music they like, that would be observational. You could pick a random sample of people, separate them into groups, and have each group listen to a different genre of music, and you would collect data on the people who display an emotional response to their rap music. All right, well, that would be the same thing, but doing an experiment. All right, chiropractor wants to test the effectiveness of new muscle relaxant cream on his patients experiencing muscle spasm. He separates the patients into two groups and administers the cream to only one of the groups. He then compares the results. Which type of study best describes this situation? All right, so he divided the patients into two groups and he gave cream to only one of them. That's a controlled experiment, right? It's controlled because he's deciding who's in what group, who's getting the cream, who's not getting the cream. But it's definitely an experiment to see the cause and effect of giving one group of people cream and the other group of people not getting the cream. The Democratic Party needs to collect data on the preferences of their party members regarding a new bill that is being brought before Congress. Which method of data collection is most appropriate? Well, that would be the survey. Just ask them a question. Are you for this bill or are you not for this bill? You wouldn't really want to observe them, and you wouldn't really want to do an experiment. College dorm has 5 common areas in the building. The college wants to convert one of the areas into a workout room. Dorm residents are polled to determine which common area is used the least. Which type of study does this represent? Well, if you poll somebody, you ask them a question, that again is a survey. All right? We have to talk about bias. Bias is favoring a certain way and it skews the data. Avoid bias by using a random sample. You always want to use a random sample in statistics. It's very easy to manipulate the data in statistics to go the way that you want it to go. So you definitely want a random sample at all times. So let me show you an example of something that's not random. Describe the possible problem with how the participants are chosen in each of the following cases. So A, suppose we want to know how long students at the high school spend doing homework last week. We go to the school library and ask the first 30 people we encounter. The problem with that is people at the school library probably spend more time studying than the average person. That might not always be the case, but there's definitely the potential for bias there. All right, so people at library usually, not always, but usually spend more time studying. Certainly more time studying than, maybe if you go to the gym and ask, all right, but they usually spend more time studying than the average person. So there's the potential for having bias there. Suppose the school district wants to determine if the community would be in favor of installing a new turf field, and they survey the parents at a football game. Again, that's not a random sample. All right, they're asking parents at a football game. Parents at a football game usually like sports. And if they like sports, they might be inclined to agree to wanting the turf field, whereas if you ask the community in general, they might not be as inclined to want to put money towards a turf field. So parents at a football game like sports would be more inclined, not always, but they would be more inclined to want a turf field. All right. Suppose we want to determine how much sleep high school students get on a typical night. Survey the first 100 students to arrive to school on a particular morning. The problem with that is the first 100 students got up earlier. It's not a random sample. And if they got up earlier, now this might not be true, but if they got up earlier, then they are on time. It's not random. They might have been on time because they went to bed earlier and they got more sleep. And the people who did not get as much sleep are more tired and they have trouble getting up and they're not there on time. All right, so there's just a potential for bias. It's not guaranteed, but there's a potential. Suppose we want to like to know the average number of hours a CI student spends doing his or her English homework. How might we go about finding this information? Well, I think the easiest way to do that, you wouldn't want to observe how much time people spend doing their homework because they potentially would be doing their homework at home and then you're not observing them in their home. So the best way to do this would be a survey, okay, and go to the English classes. Everybody in the English classes is taking English, whereas if you went to the music classes, not everybody in music is necessarily taking English. Most people take English, but not everybody. What is the population? Well, the population is the students in school taking English, which again is most people, but not necessarily all. Somebody could potentially be done with all their English classes and just taking something else that they're not done with. Is it possible to reach the entire population? Yes, but might want to do a sample. It depends on the size of the school. We have a pretty large school. It is possible, but I think it's definitely, people spend a lot of time and money doing surveys. They're very time consuming. So to reach the whole population isn't always possible. Most of the time we just do a sample. Okay, sample would definitely be easier. But it is possible. If you wanted to use a sample of this population, how could you avoid bias? Well, don't just go to one type of class. If you went to just only AP classes, they might have more homework. They have a lot more reading and writing to do. If you went to a credit recovery class, they might not be assigned homework. So you just want to make sure that you're going to a random sampling of classes, not just one type of class. How could you pick a random sample? Well, you can pick 20 classes out of a hat. You put all the English classes in a hat, and I picked 20 classes out of a hat. That would be random. Now, you might get some AP classes, you might get some credit recovery classes. As long as it's random sample, then that's okay. You're not just getting all of one type of class. All right, what is the least likely to contain bias? If you survey a sample of people leaving a health food store to determine the number of times per week that the person eats only healthy food. Well, people at a health food store are they're probably eating more healthy than other people. That would definitely have bias. Surveying a member of the basketball team to determine the most watched TV sports. Well, somebody on the basketball team likes sports and likes basketball, so that also would have bias than the general population. Surveying a sample of people leaving a supermarket to determine which color iPhone they have. That was probably the least biased, but let me read the next one. Surveying a sample of people leaving a restaurant to determine the average number of times a week that person eats out. Well, the people that are leaving a restaurant definitely eat out, so again, that's not a random sample. So, yep, it was C. In an attempt to avoid bias in observational studies and surveys, the best thing to do, assign students to a control group, select students at random, analyze the data the same day, publish the results in a well-known journal or magazine. Okay, so the best way to avoid bias is always to have a random sample. It doesn't matter if your subjects are in a control group. It doesn't matter if you analyze the data the same day or next week. It doesn't matter if you publish it in a well-known journal. But if your subjects are not, if it's not a random sampling, then it really doesn't mean anything. The study's not worthwhile. All right, and last one, for each of the following, identify if it's a survey, an observational study, or an experiment. So a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played a video game that they had never played before. The time it took them to reach a certain level of expertise was recorded. All right, so you might think that this is an experiment, but I'm not doing anything to cause a particular effect. This is really just an observation. You're observing to see who does the game quicker, who's quicker to learn it, what's the, what level of expertise. So that's observational. As your statistics project, you collect data by posting 5 questions on a poster board around your classroom and recording how your classmates respond to them. Well, that's a survey. It doesn't matter if you do a survey on the phone, on a clipboard, or on poster board around the classroom. You're asking a question and they're responding. The local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 and paint B to the other 10. The department finds that paint B lasts longer. This is definitely an experiment. You have 2 different paint types and you're experimenting to see which one lasts longer, and you are putting some on, one type on road, type A on 10 roads and type B on 10 other roads, and seeing which lasts longer. That's an experiment. The National Highway Traffic Safety Administration conducts annual studies on driver seatbelt use at a random selection of roadway sites in each of the U.S. To determine if seatbelt usage has increased, data is analyzed over the next 2 years. So you're not doing an experiment and you're not doing a survey. You're not asking people if they wear seatbelts or not. This is observational. Okay? And just a little summary, when reviewing a statistical study, some things that you should keep in mind. Whether the group collecting the data has an interest in the outcome of the study. If the group collecting the data has an interest in the outcome one way or the other, then that might not be the best study. You want to know whether the study is recent. You don't want a study that's 50 years old. You want to know if the sample size of the study was sufficient to generalize the findings. All right, you don't just want to ask 5 people and all 5 happen to agree and you say 100%. Well, that's not really a great study also. You want to see whether the data used was complete data or was a condensed form of the data. Basically, all of the above are true. All right, so that's the 3 different types of studies. Lesson 1.